Mastering computer vision. Data is only as good as its intake, annotation, and recall strategy. When implementing computer vision applications, what is the process by which data is typically ingested and stored, considering factors such as data quality, annotation, and retrieval efficiency, to ensure seamless operational excellence in the entire machine learning lifecycle? Implementing operational excellence in computer vision applications requires a well-designed data management strategy to ensure seamless data ingestion, storage, and retrieval. The process typically involves the following stages. Data ingestion. 1. Data collection, gathering data from various sources such as images, videos, or sensors. This step involves identifying the data requirements, defining data formats, and establishing data quality standards. 2. Data pre-processing, cleaning and pre-processing the collected data to remove noise, correct errors, and transform data into a suitable format for storage. This step is critical to ensure high-quality data that is suitable for machine learning model training. Data storage. 1. Data warehouse, designing and implementing a scalable data warehouse to store large volumes of data. This can be achieved using distributed databases, data lakes, or cloud-based storage solutions. 2. Data catalog, creating a data catalog to track metadata, data provenance, and data lineage. This enables efficient data discovery, retrieval, and reuse. 3. Data versioning, implementing version control systems to track changes to data, models, and algorithms. This ensures reproducibility and auditability throughout the machine learning lifecycle. Data annotation. 1. Data annotation framework, developing a data annotation framework to ensure consistency, accuracy, and efficiency in labeling data. This can be achieved using human-in-the-loop annotation, active learning, or weak supervision. 2. Continuous annotation, implementing a continuous annotation process to ensure data is up-to-date and reflects real-world scenarios. 3. Data validation, validating annotated data to ensure quality, accuracy, and consistency. Data retrieval efficiency. 1. Data indexing, creating data indexes to enable efficient data querying, filtering, and retrieval. 2. Data caching, implementing caching mechanisms to reduce data retrieval latency and improve system performance. 3. Data queuing, implementing queue-based architectures to handle high volumes of data and ensure efficient processing. Operational excellence. 1. Monitoring and logging, implementing monitoring and logging mechanisms to track data quality, system performance, and model performance. 2. Automated workflows, automating data workflows to minimize manual intervention, reduce errors, and increase efficiency. 3. Continuous integration and continuous deployment, C/CD, implementing C/CD pipelines to ensure seamless integration and deployment of machine learning models. 4. Collaboration and knowledge management, establishing collaboration frameworks and knowledge management systems to facilitate knowledge sharing, reusable code, and best practices. Ensuring seamless operational excellence. 1. Feedback loops, establishing feedback loops to ensure continuous improvement of data quality, model performance, and system efficiency. 2. Experimentation and A/B testing, encouraging experimentation and A/B testing to evaluate new techniques, models, and algorithms. 3. Training and knowledge sharing, providing training and knowledge sharing programs to upskill teams and ensure collective understanding of best practices. By following this structured approach, organizations can ensure operational excellence in computer vision applications, leading to improved data quality, increased efficiency, and enhanced model performance.